Hey, hi friends. So today actually I am going to explain about one of the famous interview questions, which is nothing but least recently used cache implementations. So whenever we are saying cache, it means that as you know already concept of the cache, it will keep the least recently used data, and if any data which we are going to recently use, and if the size of the cache is already full, then it means that last data it automatically it will be removed and new element it will be added into the first. Similarly, suppose that there is any data which is already present and again we are using, then it means that it will be come into the top. It means that head basically. So this all is the operation of the LRU. So for the implementation purpose, what I am doing, uh, f- these basic four methods have to use contain in cache based on the whatever the data it is there. If it is present, then it will return the true or false value basically. Similarly, delete from the cache, it will have the void. It's nothing but based on the data. Again, it will be delete the data. Similarly used and contains in cache. Okay, so 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 how it will be. So see, for the implementation point of view, what we will do, we will we will since see since this is the cache. Okay, so how we will structure our data basically. So first thing is that we have to fastly travel, we have to keep the map. It means that we are based on the data or based on the key of the object basically, we will put the detail node basically here. So here might be the detail node and this is the key basically. Key for the simplicity purpose, key whatever the data is there, just I am taking that one. But when we will go for the real implementation, then key will be nothing but it's kind of the basically the primary key. Based on that we can access the data basically, key value here. Okay, now since every times we have to understand what is the our head and what is the tail, so according to that whenever it will be full or it will be empty, so we'll be able to judge it. So there should be link, there should be the two nodes, two pointer basically, which will capture the head and tail, first element and last element basically. Okay, first element and last element I am going to capture. So this always it will be changed whenever we are doing delete any data from the cache or adding any data into the cache. Then adding any data, it means that since it's always recently, so always head will be updated number. And whenever we are going to remove the data, then always from the tail we will remove. We will not remove the data from the middle of the element, right? mm, okay, means practically. So always last element it will be deleted whatever the data, if data size is given, right, means max. And since I set key for the simplicity purpose, I in the beginning I will think that the max size is equal to 5. It will be only the 5 object we will keep. So what is the logic actually? Logic is very simple. Okay, let's come with how we can delete the data. So data deletion whenever we are saying, so think is this is the like a node. Again, this is a node structure. Even though this structure also we are keeping into the map for the fast retrieval, so based on the data, but actual data it will be stored into the linked list. Okay, got it, right? Actual data it is just stored into the linked list, and their references based on the key and value directly we will. Now see, now this is the element x1 and we want to delete any node, right? It's a more or less delete the node. So delete the node, it means that there might be the three circumstances. Either you are going to delete the head itself. Head itself, it means that either the data which need to delete, we have to delete this one. So in this case our head it will be moved to the this one, and their references means next and before references it will be modified. This is the double linked list basically. Okay, so head and will be, and according to that whenever we are going to delete, then it means that we have to remove from this section as well, right? And if the tail is there, it means that tail it will be modified. If the suppose that there will be the middle element or any one of the middle elements, so in that case what will happen? If the middle element is there, it means that next of next means before of the next equal to this element, and there before equal to this element, and we will nullify this one, right? Then it will be delete the data. Okay, so these are the three scenario basically whenever you are going to remove the data. Now see how you will be add the data, right? So adding the data, it means that whatever the data you are going to use, right, or you are going to add, it might be exist into the cache or it might not be exist. Suppose that this is the exist into the cache, then it means that suppose that there is some element is there, like example as this is the 2 element and 2 is already present into the cache, and you want to use these 2, it means that their position it should come into the head, right? Because it is at least recently used, it should not go, so it should be always updated into the head. So in that case also we will first call to the delete method, and then after that we'll create the new node, and the new node is more or less is kind of addition into the beginning. So our head it will be modified with the new node. Okay, and suppose that this is the first condition where it might be the data which we are going to add, it is already exist. Second condition, whatever the data we want to add, it might be not present, right? So in that case what will happen? Simply we will add into the beginning. And so in that case what we will do, if head equal to, if suppose that cache is purely empty, there is a head is null, tail is null in beginning, right? Whenever it will be initialized. So in that case nothing but we will create the new node and we will say that this is our head, this is tail, and put into the map. These three. These two are the pointer, main data structure is this, and this is the linked list. Okay, and if this is already data is present, means we have the node, and in the node you know that it's already present. So in that case what you will do, you will check that size, right? One constraint which I am saying always, this is also the one of the constraint, right? Maximum size. If suppose that whenever we are adding to the element into the cache and our size is going to increase the max size, so in that case first we have to delete the tail node, and then after that we have to add simply. Okay, so this all is the term is the conditions. So I hope so you got it. So basically whatever I said key, this 4 contains in cache since it's a map, just we will apply the map element, map inbuilt method, right? So let's jump into the coding. So like what I explained here, So here is nothing but like I said, we will take the two pointer which is head or tail. Our actual data is in the linked list, and for the fast retrieval we are taking the map. So based on the data, based on the key, directly we can access our node. Okay, and similarly max size, currently just I have hard coded 5, and current size equal to 0 in the beginning. Now see, contains in cache, map dot contains key, it will be returned. Now delete from the cache. Whatever I explained that if node equal to null, this will be the base condition. There is nothing to delete it, right? If the already node equal to null, there is no found. If it is there, then we will remove the data, remove the data, uh, and if whatever the data we are going to remove, right? And current size is always 1. It means that there is a single element into the cache. So in that case, after removing, it will be head and tail. It will become the null. This is the first condition. Second condition, whatever we are going to delete, this is the head only. So if we are going to delete the head, it means that we are modifying the head element. Okay, head equal to head dot next, and head dot before equal to null. Just I am giving, and node equal to node of next equal to null. Okay, so this is nothing but removing the head element. If suppose that there is a data which we are going to remove, that is a tail element. So in that case, tail equal to tail dot before and tail dot next equal to null. Okay, and similarly here before the tail dot before, okay, tail equal to tail dot before, tail equal to tail dot before. So uh, node equal to tail, we can say like this also. Okay, and the tail equal to tail dot before, now tail is modified, tail dot next equal to null, and node 1 dot before equal to also null. So there is no any reference, so it will be automatically uh, collected by the garbage collector. Okay, so it means that we are removing this reference also. Okay, since we already removed from the map, and now from the linked list, here I remove the tail. Similarly here, if we want to delete in the middle element, it means that if suppose that this is not a head, this is not a tail, something in the middle element we are going to remove. So in that case, what we will do, we will perform this operation. Okay, so like I said, key first we will identify what where is the before, where is the next. Now before and next, they want to link to each other, right? So so here if you will see, just I am linking both node here and nullifying the node. So this object, it will be node linking mode with the current linked list. Okay, so this one is the delete from the cache. Now add into the cache. Whenever we are going to add, again the condition is same, either the it will be the beginning node. So in that case, just create the node, and head and tail both will be the same node, same pointer, right? And put into the map, and putting into the map here last. Sorry, here I have to put map dot put data and node, data node. data comma, because we need to track this data, right? Since we are returning here, so that's why I putting. Otherwise, what we can do, yeah, it's okay. And if suppose that there is a greater than size, then if there is a greater than size, it means that tail we are nullifying and removing from the linked list and adding into the removing from the map also after the. Okay, and first element it is the head equal to none. Okay, okay. Now below is nothing but if suppose that this condition is not true, first condition, this condition is also not, it might be the true or false, it's independent. Means it will be executed when the our linked list or our node is not empty. So in that case we are actually adding the data, okay, here, and into the linked list, as well as the we are modifying our head. And now see how to use is nothing but like I explained already, it nothing but if it is contained, then always we will delete from the this node, and then after that move into the first place, right? So this is the step which I am doing. Means suppose that already it is used, it already exists the data, it means that this is already exists the data, then first we have to remove this one, and then after that put into the beginning. So delete from the cache, and then new node assigned to the head, and head dot before equal to node, and putting into the this data into the same into the map. So again it will come into the first place, otherwise add into the cache. Okay, so I already explained. So let's try to test it, the same thing. So if you will see here, this is nothing but 5 element I added, so it will return the 5 element. After that, sixth element I am adding, so it means that this element it will be removed at this place. Again I use the 5 which is already exists, so again it will be come into the top, and again in the 9 is also will come into the top. Okay, so let's see here at this point, since 9 is here but recently used, it means that it will become at the top. Okay, see, so if you will see, this is nothing but first element. If you will see here, least recently used element is also on the top, 89 9 89 here. Okay, so this is the 89, then 5, then 4, 9, 8, right? Like that in this list recently. Then at this point, what I doing? I adding to 78. So 78 is coming the top. Again, I next time I adding to the 5, which is already exist. So if it is already exist, then 5 it will come at the top. Okay, and even though here you can test how we can delete the particular element, means sometimes you have to evict the element, right? Like many cache based implementation, if you will see, they are also providing the evict method. So evict method is nothing but delete from the cache particular data. Okay, so I hope so it is giving the expected result. Thank you.